So we're going to focus on the hardest of the three situations because I think the things we do will apply to all of them. So who would like to pick which one they think is the most difficult looking equation?
Not
Brady?
one.
Which one are you thinking, Brady? Three you thought looked the hardest?
Yeah.
Okay, so x plus 4y equals 28.
Oh, it goes up there?
Where x is the number of games, and I kind of like to get it organized, and y is the number of rides. It's also labeled on our x and y axis, but I just like writing it somewhere like this too. So, okay, so the next thing it says is, what is the number of rides the student could go on if they don't play any games? So who can tell me the answer to that and how you know? So how many rides can this person go on if they go no games? Tadas, what do you think?
They could go on 7 rides if they play any game.
Okay, and then it says on the coordinate plane mark that spot, so let's do that. And it says to write the coordinates. The coordinates of that would be 0, 7. So there it is. 0 games, 7 rides. That's the spot, right? Label it. We're done there. So number 2, what's the number of games they could play if they go on no
28.
rides?
28.
Noah.
28.
28. How do you know that?
Because if y was 0, then it would be x plus 4 times 0, which is x. It's just x, and x equals 28. So
I like that. So he's saying if I slap a 0 up in there for y, which means no rides, all I'm left with is games. And if each game is $1, I have $28 to spend on games, right?
Yeah.
So here's those 2 points. These 2 points are called the x and y intercept. The word intercept means like where it crosses, right? So these are called the intercepts. And the intercepts are nice when our equation's in this form. This form is called standard form of a line. Okay, so intercepts are nice with standard form. Would you agree, especially in context, pretty easy to find these numbers in all 3 situations? Maybe especially the x plus y one. Anyway, it says connect. I'm going to try my best to draw a straight line. Okay, that was pretty good. And next, here's what I'd like to do. I don't want to switch the slide because I want to keep this up. Who can read me the next question from the packet? Raphael?
Draw a line to connect the 2 points you've drawn.
Nailed it. Okay, what's next?
Complete the test to make the
Yeah.
play no game. You did that?
So if they played no games, yep, we did that. If they played no games, they got 7 rides, right?
Yeah.
No games equals 7 rides. Okay, I'm going to circle that, okay? What's the next thing say?
What is the slope of the ground?
I think before that, doesn't it say something like, does it increase or decrease? Each game you play, what does that do to the number of rides we can do? What does it do to the number of rides? It decreases by how much each time?
4.
You're onto something here. But a game is $1. It takes $4 to do the ride. It decreases by 1/4.
Well, if you only had $4, then
You just can't do a full one, right? But yeah, it's decreasing it by 1/4 of a ride each time. Okay, can you follow that?
If you only had $4 and you decrease 1, then you wouldn't be able to play on your
If you only had 4, but
it's
we have
not like you can just get off and forth.
yeah, but we have $28. So in essence, each time we play a game, we lose 1/4 of a ride.
Yeah.
Can everybody follow that? Okay, the next thing it says to do is solve for y, right? So solve the equation for y. And here's what's cool. We learned that we can make equivalent equations by doing the same thing to both sides. So I'm going to go here. I'm going to rewrite my equation right here in blue. And if I'm going to solve for y, what might be the first thing I'd like to do to both sides? Keeping in mind that we're making equivalent equations. Subtract x. Bye-bye, x. And so I get 4y equals negative x plus 28. You could also have 28 minus x, and it's the same thing. Okay. How do I get rid of that 4, Connor?
You minus 4y.
4y minus 4 is 4y minus 4. So 4y means 4 times y. How am I going to get rid of that 4?
Divide by 4.
Divide everything by 4. So here's what this is going to give me. Y equals negative 1/4 x plus 7. Now here is connection time. The first question I'm going to ask you is, in this format, what is y still equal to?
7 rides.
Rides. So now my whole equation is set equal to the number of rides. It's in terms of rides, right? Over here, it was set equal to total money. Do you guys see that it's set equal to something different now? So really what this says is the number of rides is equal to losing a fourth of a ride for each game plus $7. Kind of cool, huh? So same equivalence, it just tells us a little something different. Just like when we had trucks and cars the other day, and we solved for trucks, or we solved for cars, right? So, another thing I want to point out, check this out. No games is 7 rides. Where's that showing up here?
At the plus 7.
At the plus 7, because like Noah said earlier, if I threw a 0 in here for x, what's anything times 0?
Nothing.
0. So when x is 0, y is 7 every time. Also, so that's called the y-intercept. What is the x value no matter where we're at on this line forever?
0.
0. X is always 0 on this line because it's not left or right at all. Okay, this decreased by 1/4. Where did that manifest itself in this equation? The slope. Because we're in terms of rides, our slope is going down 1/4 of a ride each time we play a game. We did it in context, right? Do you see how our equation matches it? We could have solved for x as well, but normally a line is going to be solved for y like this, and this is called slope-intercept form. Any ideas why? Yeah, it's because it has a slope and an intercept in it. Fancy name. Just kidding. It's called slope-intercept because there's a French guy. His name was Slope-Intercept, and he discovered it, and so they named it. They named it after him. Slope-intercepted. Yeah, thanks for clarifying that for me, Remy. No, I'm joking. It's because there's a slope-intercept. And what you'll see it as, let's do it in red just so we got a lot of stuff going on here. Slope-intercept form, you'll usually see it written like this. Y equals mx plus b. Where m is slope and b is the y-intercept. Y equals mx plus b. So you saw that form no matter which equation you chose. So we're going to roll through this together. I'm going to try to get you a little bit of homework time today.
Why does Andre always
Okay.
do this?
So we've got Andre. He's got a jar. It has 85 cents. No quarters, no pennies. And no weird things. No 50-cent pieces or anything. So no quarters, no pennies. That means he has
What about dollars?
nickels and dimes. Okay. So who can get this into an equation for me? Who'd like to try? Who's that? Oh, I can't see a face. Is that Olivia? Oh, no, Orly. Orly. Just say it a little louder. I just can't hear you. Okay, so 0.85 equals 0.1d plus 0.05n. So we could do this, but look at our scale along our x and y here. That's going to be in pennies. So I'm going to rewrite an equivalent fraction, though. That's a good equation, Orly. 85 equals 10 cents per dime plus 5 cents per nickel. It's the same equation, but this one's in cents instead of dollars. And I think this one will work nicer because, check out, again, our scale looks like it's in pennies. So here's an equation. Everybody go with that equation matching up?
Yeah.
Okay. Now I'm gonna say then that the x value is dimes and nickels is my y value. Let's graph it. What was the easy way to graph all those last equations? What did we do to get our reference points kind of nice?
The intercepts.
We did the intercepts. And the intercepts happened we had none of one thing or none of the other thing, right? So let's say we have no nickels. How many dimes could we have?
8.5.
8.5, man. We're going to cut one of those in half somehow. A theoretical 8.5 dimes.
Yes.
If we had no dimes, how many nickels?
Let's go with
17. Actually, twice as many, right? Because 2 nickels is a dime. That's another way you could have thought about that. Let's see if I can make 2 really straight lines in a row. You think I can do it? I'm going to try my hardest. It's pretty good. Okay. Next. So we got a graph. This graph should show, in theory, all the different combinations of dimes and nickels that'll work, right? Now, we know they won't all work because, like, 50 cents, dimes and nickels. So we graphed it, we labeled it. If there are no dimes, how many nickels? We've got that. There's 0 dimes, 17 nickels. How many dimes if there's no nickels? Well, there's 8.5 dimes if there are no nickels. But here's the deal. What's weird about this point, kind of, in
You
context?
can't cut a dime in half.
Half dime?
There's a such thing.
You could cut it half, but it's not worth half a dime. It's not worth 5 cents.
Why not? It should be.
You could just use nickels.
Yeah, the moral of the story is I advocate we get rid of dimes and everybody just uses nickels only. I'm joking. I'm joking.
I have to use for the dip.
Now, here's what I want to do.
Just use pennies only.
Here's what I want to do. I want to try to see if I can find the y-intercept and slope, and then see if I can use what I know about equivalent equations to make sure I can write that equation a different way. So let's go. What's the y-intercept? That's the easy one. Remember, I'm trying to get it y equals mx plus b. What's the y-intercept? Where does it cross the y-axis? It crosses right here at 17. When x is 0, y is 17. So I'm going to write that right here. I'm going to write b equals 17. That means y-intercept. Now, how can I find the slope? The slope is the ratio of what to what? Yeah, but rise to run. So I'm going to pick 2 points. Let's just pick these two. My rise would be how much?
30.
-2. My run would be 1. So my slope is -2. So in theory, my equation would be y equals -2x plus 17.
Mr. Matt.
Wait for it. Just wait for it. In theory. Now, let's talk about this. This would say that the number of nickels used would decrease by 2 nickels for every additional dime. Would that be true? My equation says the numbers of nickels will decrease by 2 every additional dime I use. Is that true? Yeah, because a dime is equal to the 2 nickels. So that's cool. Now let's do it to it. Let's solve this. In this case, I have x and y instead of a d and an n. So I'm going to solve for n. Minus 10d, minus 10d. So 5n equals -10d plus 85. If I divide everything by 5, look what I get. N equals -2d plus 17. Boom. I know. So let's make these connections real quick. The connections we need to make is this equation and this equation are equivalent. I showed you right here in the algebra, right? This equation is dimes and nickels in relation to total. This equation is the number of nickels in relationship to the number of dimes. They tell different aspects of the same thing even though they're equal. Just like when we solve for cars to find how many trucks, or we solve for trucks to find how many cars, or almonds to find figs, or all these things, right? The flexibility here is this. On this one, we could graph by intercepts pretty easy. That's another big idea. On this one, this one down here is cool because it gives us the slope. We can see that relationship of what's changing a little easier than up here. So as we get further and further into this linear unit, you're going to see pros and cons of everything. All right? You're going to see different tools for the tool belt. I use these 2 equations differently depending on what I'm trying to do for the same situation. And so it's going to keep, there'll be more and more. So let's make sure we reviewed those, the big ideas. Right here. Can we describe connections between the original equation and the final feature graph?
Yeah.
Yeah, we found that slope and y-intercept, especially when it was in context. Can we graph it? Yeah, what was the easy way to graph in standard form?
Slope intercept.
Finding what? Yeah, Cooper. Intercepts, right? When we know 0 of this thing can have all of this thing, and 0 of this thing can have all of this thing. And then we understand how to rewrite it, solving for a variable. That wasn't new today, right? We know how to solve for a variable. So I'm going to hand out that homework, and we're going to get after it.